What's going on, guys? It's Bucky and welcome to your 8th chemistry tutorial. So now that we determined that the protons and neutrons are hanging out inside the nucleus of the atom, we have to answer the question, where the heck are the electrons? So you might be thinking, okay, they're probably in the nucleus too, why not? Well, actually, the electrons are spinning outside the atom or outside the nucleus. So what scientists, or chemists rather, did is they needed to figure out the exact path that the electrons took and how far apart they were from the nucleus, and they needed to figure out all that crap. So in order to do that, they came up with a few models. The first model they came up with is called the Bohr model, B-O-H-R, and that is because this dude named Niels Bohr, he discovered that he was pretty much the first one to discover that the electrons do kind of spin outside the nucleus and they aren't all stuck together into one main thing. However, we have a better model that we also use today called the quantum mechanical model. This was named after someone named Jonathan Quantum Mechanical Model. I'm just kidding, that wasn't his last name. A bunch of people came up with this. And the difference between these models is Niels Bohr, his model is really simple and easy to understand, and it applies to really simple atoms. However, the quantum mechanical model, this is like the version 2.0. It's more accurate and better, but it's really complicated and there's kind of a lot of math involved. So for this tutorial, I'm going to go over the Bohr model, which, remember, this is the easier one and it applies to very simple elements. So the Bohr model pretty much says three main things. First, the electrons spin, or he says orbit a lot, around the nucleus, pretty much if you think of planets orbiting around the sun, the exact same idea. Also, they only orbit at specific distances, and he called these distances energy levels or energy shells. So pretty much he's saying, okay, an electron can be in these areas, but they can't be in between. And the last thing he said is electrons usually chill at something called the ground state, or the shell or level closest to the nucleus. However, what you can do is that electron can absorb some energy and jump back up to an excited state. And maybe this would be a better picture. So this little purple globe thing is the nucleus. All the protons and neutrons are hanging out right here. And these around here are the energy levels or shells or orbits or areas, whatever the heck you want to call them. But he says that the electrons are spinning around here or orbiting around the nucleus just like this. And this one closest to it is called the ground state. So he said that just like planets around the sun, they're spinning around this nucleus just like this all the time. They never quit. And they only spin at these fixed distances, either this one right here or this one right here. But an electron can't be in between. It can't just be like this, or it can't be way out here. It has to be on this one or on this one, not in between. Now, this first one, the one closest to the nucleus, this orbit is called the ground state. However, whenever an electron absorbs energy, it can jump to another excited state. Now, I only show two in here, but there are an infinite number that you can have potentially, or theoretically, I guess. So pretty much electrons usually hang out here at the ground state. However, they can absorb energy and jump up to an excited state. And then they have a lot of energy and they're really excited, like a little kid who drank like 18 energy drinks. They also said that each of these different levels can hold a different number of electrons. For example, this first level right here can hold 2 electrons. This second level can hold 8 electrons, and it goes so on and so forth. And whenever we're talking about the quantum mechanical model, you'll figure out how many different levels can hold how many different electrons. So, with that being said, the problem with this model is that it works really good for simple elements. For example, hydrogen, that there's only one proton and one electron, maybe one neutron, really simple stuff like that. But whenever you get to other really complex elements with a bunch of electrons and protons in it, it doesn't really work so well, and this model doesn't prove true all of the time. So a better, more accurate, and also, unfortunately, more complicated model was formed, named the quantum mechanical model, and that's what we're going to be studying in the next tutorial. And that is what most chemists use today. However, for the sake of simplicity, just to get your feet a little wet, I decided to talk to you guys about the Bohr model because, again, it's still useful when you're talking about really simple atoms. So anyways, thank you guys for watching. Don't forget to subscribe, and I will see you guys next time. Remember, quantum mechanical model, it's going to be awesome.